Hello. Everybody that does not know me, hi, my name is Parag. I'm a Linux system administrator, and today's video is going to be a pretty simple laboratory, or let's call it a demonstration on how to set up a load balancing uh, type infrastructure on your AWS architecture. The premise of this video is very simple. You have an instance, EC2 instance, but you need more instance in case you need more instance, or you need to increase the capability of that instance for whenever downtime happens. We will go very slowly just to explain the concepts. The video that you see in front of you is the basic premise. So first of all, you have an elastic, an application load balancer, which then transfers you to a target group, and the target group then optionally transfers you to the EC2 instance. Now, it can be an EC2 instance, it can be it can be something else, it can be a storage, it can be anything. It depends on the request, right? An application load balancer typically has the main domain. So, for example, you are going to Amazon. So, if there are, let's assume that there are 50 lakh requests per minute, which is a valid assumption, I think, because anyway, 50,000 people are 50 lakhs. 50,000 people are going to Amazon per minute, which is definitely low. But 50,000 people go to Amazon's website, Amazon.com, and after going to it, you realize that the machine can handle only a certain amount, like one server, one EC2 instance can handle only 50,000 users per instance. So that is a problem, right? So in that case, you have two options. Either you can increase the capability of that EC2 instance to handle more users. Let's suppose you do that, you increase the memory, you increase the core count, you increase the overall performance of each EC2 instance that you have. Now you increase the EC2 instance's capability to handle 75,000 users. Now that is okay, but the number of users will not rest. It will keep continuing. What if you need 100,000 users? You need 200,000 users. So the scenario in which you are increasing the capabilities of your singular EC2 instance is called vertical scaling. Vertical scaling happens when the EC2 instance can handle more load, but there is a limit to it. EC2 has a lot of options when it comes to the type of storage, the type of services you can use. There are different types of EC2 instances that you can assign, but that limit stretches out. So in such a case, what we can do is you can have multiple EC2 instances. Now imagine you have one server which handles 50,000 requests, but those are not enough. So what do? You add another EC2 instance that can handle 50,000 requests as well, and let them work together. So in the first minute, because each minute there are 50,000 instances, in the first minute you only allow the instances, only allow the first instance to get 50,000 requests. In the second minute, you make it go to the next one. By the time it comes back, in the third minute, you can always get it back to the first instance. This is a very normal, very simplified explanation for how you can use EC2 instances, but obviously there are a lot of complex algorithms on the load balancer that will allow the instance to be chosen accordingly. Now, suppose 50,000 requests come on the Elastic Load Balancer. What will it do? It will check which of the target groups has how many requests serving to it right now. Suppose this has 40,000 and this has 10,000. So it will naturally go to the second one because it's easier. Okay, it's easier for the second one to handle it as compared to the first one. Now it will go to this second one. And now it says that here the target group has two EC2 instances. EC2 instance number one has we said that this has 10,000, right? So suppose this has 8,000 and this has 1,000. So it will naturally choose the one that has lesser number of resources being utilized, and it will send it to this one. In this scenario, when this is a horizontal sort of load balancing, you will get so many instances that you don't even need to think twice before setting this up and wondering whether my loads will get balanced or not. You can power on, like you have 5 instances right now you have 5 instances working, and then you realize, no, 5 instances are not enough, I need to add more. You can just power up 5 more instances and it will manage your load for you. This is the power that AWS gives you. Cloud computing gives you, not just AWS. Cloud computing gives you that other on-premises physical servers will not be able to give you, because you cannot just bring up 5 physical servers in an instance and be like, let's go, let's handle this load. That doesn't simply happen. Now, to demonstrate this point, we'll do a little lab. I'm sorry about that. We just follow some demonstration of how that will work. Sorry for the rant. Uh, let's just sign into my console. Yes, that is my account. I'm not using an IAM user. I don't know why. I should be using. That is my fault. I will set it up eventually. This is a test account, which is why I do not have IAM user set up on this, and I will be closing this very shortly, unless I get that $300 $300 in a fund from AWS for using their services. Now, let's go to EC2 and let's create a couple of launch templates. Launch templates are something that will be helpful for auto scaling. Auto scaling is a concept that I will be sharing in teaching you in this, not teaching you, demonstrating in this particular instance. We actually need to go to a launch template. So we have a couple of instances templates with me from a couple of older demonstrations that I've done, but we'll create a new launch template. Let's call this temp2 for very simplified purposes. What do we describe this as? We will describe this as anything. Let's give this and yeah, let's give this. Should we give it this? Let's give it this. Amazon Linux, correct? Let's keep it this. Let's give the instance type as T2 micro, because that's a free one. But for auto scaling, I'll show you what instances are available. You have T2 small, T2 micro, T3. Let's just open it in the big screen and let's just see, right? So this is the second smallest, this is a free one. So we are going to use this. Otherwise, there are a lot of other instances that have huge performance benefits. The best is the C5 9X large, which has 36 vCPUs, 72 gigs of memory, 900 GB storage, and 12 gigabit network performance. I assume that is bandwidth, but this is, I think, no. Where am I? Cancel this. Just let me make sure that is the largest one. But there are multiple such options. Okay, 20 gigabyte. Why is this storage space empty? Okay, maybe I need to add. Oh, it's empty because you need to add S3 to it. Instance type T2 micro. Yes, T2 micro. We do not have a key login pair, but I have created one earlier, which is new SKP. This is basically something I had made earlier. You can make this too. If there is a requirement, I will make a video on it too. We have a security group as well, which is Linux SG. As I've mentioned in my earlier videos, this is basically having SSH access and ICMP for access from anywhere in the world, just so people I can access it from wherever I want to. Let me just see if I've added the correct things. Do I need to give a description? Template for auto scaling. That's it. This is it. Okay. We have to have an EBS volume because this is something that will have our storage. We need to have user data as well. User data is something with which we can run our website. I'll just quickly check this though. I did have something already saved, so I will just check that. I'm so sorry, this is taking just a little bit longer. Nope, this is not it. Yep, this is it. So I found one. I'll just share it with you. Just check where the user data is. This is the user data, right? Let's call this running on AWS for around me. Let's call this 0 so that we can have another one. Let's copy this. Let's keep this. Let's create a launch template. So we've created a launch template now. The launch template is ready, and with this launch template, we can launch an EC2 instance, right? Just before we do that, let's just go to EC2. Let's just close these tabs. Running instances, I have no idea. Let's go to auto scaling first. Let's go to auto scaling. Where is it? Where is it? Where is it? Where is it? Let me just search for it. No, 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 no. Okay, scaling. Yes. But it's in EC2. Why can't I find it? Do you see auto scaling anywhere here? Here it is. Go to launch configurations. Okay, let's go to, oh God. Let's go to auto scaling groups and let's create one auto scaling group because we need an auto scaling group that is an application load balancer. On top of it, we will create just one target group, and on that we'll create a couple of instances. Okay, so this is not free. So yeah, no additional fees beyond the service. Just ignore that. Okay, let's go to auto scaling group. Let's create auto scaling group and let's name this ASG1. Okay, let's select the launch template. We have temp2 that we created right about now. Version, let's keep it default. We don't need anything much. Just click on next and then we go to subnets. Now we have subnets. We have VPC. Let's keep it the default one. We don't need to do anything new. Let's select 1A and let's select 1B. You don't select 1C because it has some issue with AWS Amazon Linux too. So don't do it. Just don't do it. It's a trouble. So maybe if they fix the bug, I'm not sure what was the problem, but it is causing some problems. Okay, with the network and the AWS Amazon Linux too. So let's make this. Let's go to next. Let's see. Okay, sir, there are three load balancer options that you will see. Let's just select. Do we have an existing load balancer? Okay, let's ignore this. Let's create a new one. Let's not go back. We need an application load balancer. Now, once you selected that, you need to give this a name. What will you name it? It's really up to you. I'll just keep it as it is, but we need this to be internet facing because the traffic that the application load balancer will get will be from the internet, right? So once you've selected internet facing, you need to select the VPC, which is the default one. No, not a big deal, not a big problem. Default, create a target group. We'll create a target group for this. Does this have default routing or does it not? Episode 1, episode 2. Where is application load balancing? Yes. Internet facing? Yes. Am I missing something? Oh yeah. Select, create a new target group. Just select the click on new target group. It will create a new target group for you. I was a little confused. Okay. Do we need to name it anything? Oh, let's not name it. Let's just keep it as it is. Okay, we have a new target group and it will be created very, very soon. Okay, let's just keep it internet facing, have a new target group. Okay, now there is this no, let's not do this. Monitoring. Let's go next. Let's go next. Okay, this is the part that is the most important. Now, the desired capacity asks you how many EC2 instances or whatever service or application that you're using, the tool, the service that you're using from AWS that you need. For us, Let's keep the desired to 3. The minimum that we need, let's keep it to 2. 0, 2 actually. The maximum, let's go to 4. So this is the place where Amazon does most of its work. So Amazon will realize that this client needs at least 2 instances to run, and it needs maximum 4. Even if the load increases, do not exceed 4. That's it. That's all you need to do. Once you've selected this maximum capacity, scaling policies, do we need to do something here? Okay, let's create a scaling policy. Now the target value is 50. It's the average CPU utilization. Let's not keep it to more than 50. Let's just keep, you can change it according to your plan, like average networking. So if the number of traffic coming in increases, you can increase that. It's pretty much the same. It really depends on the type of application that you're using. If this is suppose a video streaming platform, then you can keep it as the bandwidth. If it is more of a it's more of a CPU intensive task, such as if this is a weather forecasting app and there is a lot of info that you need to put in. Let's put it as CPU. If this is just some information app or video streaming platform, you can keep it as network out or network in. It really depends on the type of application. You can test it out and check it out. Okay, let's just keep this as 50. Instances need 30 seconds. That is not a problem. The policies disable scaling to create. No. You do not. There are instances where once the application is increasing, you do not need to scale it down, but there are times when you do need to scale it down. For example, suppose it's a social media platform, and suppose there are 300 users created, and you need that. But suppose they increase to 5,000 tomorrow, you do not need to decrease this load balancing on it. You need to keep those servers, you need to keep those instances running. But in scenarios such as you're using a gaming platform where there are guests that are created. Suppose it's a card game and 500 users are logged in today, and tomorrow it might be 50. So in that case, you can increase or decrease. That really depends on the type of application again. So I'm not. Do you need to add this? This is basically that. You can disable the instance, but only from root. So this is something you need to set an IAM user for. I won't keep this active because I don't really. This is a test environment. I don't really care if it gets deleted by some random user. So it's okay, but you need to put this. So let's click on next. This is added EBS volumes. Yeah. So this is done. Now you need to go to review. Yeah, this is okay. I don't need much. Yes, we are done. We are done. So let's go check updating capacity. It's chill. You don't need to worry much about it. Let's go to EC2. Let's go to first. Let's go to load balancing and select target groups. Let's check if everything is done in industry. It might not be, but let's just first check if the instances are up. Are they? Oh, what? 3 instances. Oh, we put the desired 3, right? That's why it's 3. So we have 3 instances running right now. They are being initialized. We don't need 3. It still are 3. Can't do much about it, right? Let's go to load balancing and let's select target groups and let's check how many instances are healthy right now. Just refresh. Select this, and we have 3 target groups, and none of them are healthy right now because none of them are up. Once they are up and running, the check will show. You saw that 300, right? So 300 seconds until like 5 minutes until they show they are ready. But if they are up and running, they will show up as healthy instances. Otherwise, they will not. Now, let's go to load balancer, and let's copy the IP, right? Let's copy the IP. Oh, it's still provisioning. Nothing. Okay, let's just wait. Will take some time. This will take some time. Let's just wait, right? Let's just wait. We have some time to kill. We have 3 EC2 instances still running. Yes, still being initialized. Come on. This is a public IP4 address, but this should not be something that we copy or this thing from because it won't load. Because this is handled by one. Oh, this is running. Let's just deselect this. Let's select this. It's 244. Let's check if this is running. This is also running. Let's check another one. Let's just check if all of them are up and away. Now we have all three of them in the running state. Now let's just select the load balancer and let's just check if still provisioning. I don't see how it is still provisioning. Two availability zones, the ones that we had selected, AP1 and APB. So 1A and 1B, both are up, both are running. So this is, what is it? Just copy this. Let's just run this. This is supposed to be working now because this is the AWS Amazon load balancer. This load balancer will pick up any one of these. There is little to no way of knowing which one is running, which of the instances it has selected. But what we'll do, just for confirmation, just to check this works, let's just go to instances, right? Let's just delete the first one, right? Let's just terminate it. Let's not do anything more other than terminate it. We need 3, right? We need 3. So let's just terminate that. Let's just wait for a while. Let's refresh, right? Let's refresh. One of them has gone down for sure. Let me just refresh this just to check. This is up. This is up. But this should not be up because we have just deleted it. Now it won't load because well obviously it won't load. It's just going to spin round and round, but it will not load. Now just to see if Amazon does anything about it, it should to be very honest, let me just delete another instance. Let's terminate it. Let's terminate this other. So now we have 2 instances that are terminated, but as you might understand that auto scaling is the feature that will enable it, the load balancer to make it again. So deleting them will uh, not actually stop the instance. They will get created again. So the minimum that is required is to just go to auto scaling groups. Click on this. How many healthy instances does it have? Desired 3, minimum 2. So the capacity is updating right now, and once it knows that another is deleted, it will create another one on its own, so that the load that the internet is sending towards the group will get handled. This will load because one of them is up. This is the power of horizontal scaling. You just need to type in X number of minimum instances, X number of desired instances, and X number of maximum instances that can run on this platform. Right now it is 1, minimum is 2, so it will automatically create another one. I realize I'm saying automatically a lot. Come on, but this will take a lot of time. I do not want to pause this video just to show you all, but it might be necessary. Let's not go to monitoring. I understand this will take a lot and lot of time. So the some time that you expect here is going to be a long. Let's just refresh the whole page. Let's see if there are any changes that will happen here. Voila, this is it. Finally, we have two instances running. I'm not sure this is the one that we created. Is 70 one of them? Yes, 70 is one of them, but this other one is not something. We have 65, which is not one of the IP addresses here. This is down. Yes, I believe this is down. This is up. So this will go down soon. But let's just check this. And hola, it's running. So we have created a very simple load balancer, but this simplicity works very well for organizations that need a lot of horizontal scaling, and horizontal scaling is the way to go. So whenever you're creating, and this is just a piece of advice, a tip for people that are just trying this out. So this is just an advice. Whenever you create, do not go in for vertical scaling. Vertical scaling will cost a lot and much more if you just waste your time on it. Instead, create AWS instances that are small, but okay, we have 3 running now because the desired amount that we put in was 3. I'll just delete all of this because this, if left unchecked, it will cost a lot of money. So first we'll delete the target group because delete it, just delete it. Terminate. Yes, delete. It's currently in use. So first, do we need to remove the instances first? Okay, let's just remove the instances really quickly. Instance state, terminate instance, terminate. Let's go to target groups. Let's go to actions and let's delete this. Delete. Okay, I'll delete this on my own time, but this is the video. This is it. This is all we were going to do. Delete everything as soon as possible so that you're not charged for it, because I assume you're using a free account. Yeah, thank you. That's it. Thank you for watching this video. If you enjoyed this, please consider subscribing, liking the video so that I get a little more exposure. Thank you.